Hello everybody and welcome to today's lesson on applications of quadratic functions. Our objective for today is we will model and solve real-world problems using quadratic equations. In order to do this, we are first going to do a little review of statistics, and specifically we're going to talk about correlation. Remember correlation from Algebra 1? We can determine the correlation between data by putting data points into a scatter plot and looking at the shape that emerges from that. Let's imagine we had a data set and come up with points that are distributed something like this on our scatter plot. If this is what we would find, then we talk about positive correlation, which means that the y values move in the same direction as the x values. Now, we could also possibly have a picture that looks like this. And I'm going to put another point up here. So, if we looked at this and we see that the y values are going down as the x values go up, we talk about negative correlation. Negative correlation means that the y values move in the opposite direction of the x values. As x goes up, y goes down, and vice versa. And then it could happen that we plot our data in our scatter plot, and this is what it looks like. And if this is what we find, we have no correlation whatsoever, which means that there is no pattern. The y values move at random compared to the x values. There's no pattern. They don't go in any one direction. How can we use a scatter plot? We can use it to predict various outcomes when we are given a certain set of data. Like in this table here, where we have the total grams of fat in a certain type of sandwich and the corresponding calories that the sandwich contains. In order to do that, we usually use our calculator, and therefore it makes sense for us to remember the steps on the calculator, and I will note them down for you just now. And here are the instructions. First, we press Stat Edit to put in our data. Then we press second, y is equal to 1, and enter to turn the stat plot on, in other words, to see our scatter plot. Then step 3, we press zoom and 9. This is zoom stats of all the different zoom functions we have there. That will zoom in on the data we actually have. That makes it easier for us to see them, and we use that information or the look at that graph to decide what type of curve are we actually dealing with. Is it going to be a linear curve or a quadratic curve? And then we go to stat calc in step 4 in order to get A and B, and sometimes, in the case of the quadratic regression, also C, in other words, the 3 numbers for the equation. This is the actual step of doing the linear or quadratic regression. So let's go ahead and do that for our example here. And remember, we have the table with the total fat in grams and the total calories. The fat are our x values, the calories are our y values. In other words, the calories move with the fat, and we want to find out how are they connected, what's the relationship between the fat and the calories. So I'm pulling up my nice calculator here, do stat, edit, and now we're going to put in the values. In our first column, we put in the x values, so 9, enter, 13, enter, 21, enter, 30, and keep going like that. And then I move over to the next column to put in our calories. 260, 320, 420, 530, 560, 550, and 590. Just check and make sure that all the values are input correctly. That is also a common mistake. Either we skip a value and then the values don't match up, we're going to get an error. Or even worse, the numbers are wrong in here, then it's going to calculate the wrong thing for us. And we won't even notice because it's going to be all decimals and we can't really see from that if our numbers are correct or not. So, in our next step, we're going to do second y is equal to 1 and enter. And now you can see the on is blinking, so now the stat plot is on. Now I go to zoom 9, and here I see my data points. And I don't know about you guys, but I think that looks pretty linear. So we are going to do linear regression. Linear regression, and this is where we find it. Go back into the stat menu, but now we move to the right to calc, and see here that number 4 is linear regression, number 5 is quadratic regression, and then there are even a couple of other ones, but we don't worry about those. Number 4 is linear, number 5 is quadratic regression, and between these two is where we have to make the decision, and we just said this is a linear relationship between the data, so we are going to perform linear regression, in other words 4. Now keep pressing enter until you get all the way to calculate, and this is what the calculator gives you. It tells you that it's basing its regression, its calculation, on the form of an equation y is equal to ax plus b, which is essentially slope-intercept form, except that they're using an a instead of an m, right? And they also give us the two numbers that we need. A is equal to 13.0907, b is equal to 145.3808. In statistics, we usually write 3 decimals, so we round to the nearest thousandth. And now we're done with the calculator. Let's write down our equation. F of x is equal to 13.091x plus 145.381. This is the linear regression equation that we can draw from the data given in the table above. And now we can use that equation to make predictions, to predict even further outcomes. As it says here, based on this model, how many calories would a sandwich with 45 grams of fat contain? Well, essentially what we're saying is that we're now finding, or we now have to find the y value, in other words, the calories for an x value of 45 grams of fat. Well, then let's plug that into our equation. So we're looking for f of 45 essentially, and that's going to be 13.091 times 45 plus 145.381, and I just went ahead and did the math for us already. The answer is 734.48 calories. This is how many calories we would expect in a sandwich with 45 grams of fat. All right, then let's move to the next example. What happens if our data isn't linear? That can happen, and we already know the answer, right? We discussed it a second ago. Well, then we're going to perform quadratic regression. Okay, let's look at this one. A pumpkin tossing contest is held each year in Morton, Illinois, where people compete to see whose catapult will send pumpkins the furthest. One catapult launches pumpkins from 25 feet above ground at a speed of 125 feet per second. The table shows the horizontal distance in feet the pumpkins travel when launched at different angles. So, as you see from the table, as the angle goes up, our distances first go up and then they go down again. Well, let's see what that really looks like on a scatter plot, and then we're going to go ahead, use our calculator, plug in the data. So first, very importantly, and it's good for us to look at that too, first we need to clear out all that old data, okay? Go back into our table, go to the top of the column, press clear and down. Don't ever press delete because it's going to delete the entire column. Clear is what's going to empty it. And now we can put in the new values. First, we're going to put in our x values. Those are the angles. 20, 30, 40, 50, 60, and 70. And now let's move over to the next column, put in our y values. 372, 462, 509, keep going like that, 501, 437, 323. Always take a look at your table again when you're done putting the values in, just to make sure that you didn't miss a value or even like put the number in wrong. Now we're going to look at what the scatter plot looks like. Second, y is equal to, well, we know the plot is already on, but just because we did it before. And going into zoom, 9 will now show us. Now look at that. Isn't that the beautiful picture of a parabola which is opening downwards? I think so. And parabola means quadratic, equation means quadratic regression. That settles it. So let's go into stat, over to the right into the calc menu, and now we're not going to use number 4, linreg, the linear regression. Now we're going to use number 5, the quadratic regression. Quadratic regression. Enter all the way through to calculate. And here you see that the equation looks different too. And what does it look like? Surprise, surprise. Like a quadratic equation in standard form. Y is equal to ax squared plus bx plus c. And those are the numbers that it gives you. And now we are in a position to write down our function that we got from the quadratic equation. So f of x is equal to negative 0.261 x squared plus 22.591x plus 23.029. Okay, that's the equation. Now we can do a lot of things with this. For example, question number 2. Determine at which angle the pumpkin travels the furthest. Well, how are we going to do that? Well, remember the y coordinates and the y values are our distance. How far did that pumpkin travel? The distance went up and then it went down again. And the highest point, in other words, the furthest distance, is our vertex. So we need to find the vertex. And here it's really asking us at which angle the pumpkin travels the furthest. So we're looking for the x-coordinate of the vertex. And fortunately, we remember, of course, that for an equation in standard form, we find the x-coordinate of the vertex using the formula negative b over 2a. Well, that's fantastic. Then let's just go ahead and do that. Negative 22.591 over 2a. In other words, over negative 0.522. And what do we get when we do this? We're going to get approximately, I'm going to make it an approximate number, 43.28 degrees. That's our angle. And if we look at the table and we see that 43.28 is between the 40 and the 50, we see those were the two largest values also for the distance. That sounds about right. And since the y-coordinate 509 is higher at the 40 than the 501 is at the 50, we can say, yeah, we're probably going to have an angle which is closer to the 40 than to the 50. So this number makes perfect sense. Guys, it's always a good idea to really use our number sense and think through, does this number that I just came up with, does that make any sense? And there you can use your common sense, and that is always a good idea. Well, let's get this wrapped up. Now we have to predict how far the pumpkin would travel if it is launched at a 35-degree angle. Right now it's asking us, we have a 35-degree angle, somewhere between 30 and 40 then, right in the middle there. How far would the pumpkin travel this time? By the way, in number 2, we could also have used the angle of 43.28 degrees, plugged it into our equation to find out how far that furthest distance really is. We didn't do that, but now we're going to go ahead and find the distance if we launch that pumpkin at an angle of 35 degrees. In other words, we find f of 35, which is equal to negative 0.261 times 35 squared plus 22.591 times 35 plus 23.029. And I've done the math for you again, you guys. The answer is 493.989. And what was the unit? Distance in feet. 493.989 feet. There's your answer. Well done so far, and now go ahead and watch the second part of this tutorial.